Hi, this is Jorge Garcia, student of electronic engineering at Universidad EXI, and this is the final project for the Telecommunications 2 course, where we are going to design a radio link project. This project consists of a radio link between one location in a city and the other location in a hill. For my project, I have been assigned the Alguacil Hill, or in Spanish is Cerro Alguacil, and the city of Valledupar. So I choose Mayales shopping center that is located in Valledupar, and we can see in the map here. And this is Cerro Alguacil. Initially, the coordinates were determined using Google Earth, where the distance between the 2 points was measured with a 39.7 kilometers. So the Mayales shopping center was chosen in the city of Valledupar, and it's located in the coordinates indicated here in the script. So we can see a shot of the city indicating the location of the shopping center. This is the photography or the shot of the location of the Mayales shopping center. And here in figure 3 we have a Cerro Alguacil located in these coordinates. Uh, the altitude of the Mayales shopping center is 152 meters above the sea level, while the Alguacil Hill is in an altitude of 3,028 meters above the sea level. So when consulting the Google Earth tool, there is no higher altitude location, such building or mountains, observed between the 2 points. In this figure, the figure 4, we can see the two locations, and we can see that there is a directly line of sight. So this is going to be very useful for this radio link design, because we don't have to put another repeater station or play with the Fresnel zone. So it's a good location with a perfect line of sight between the points. We use the equipment AF3G26X45 antenna that is similar to this, that is in the figure 5. Here we have all the technical specifications that we need to have in count. For this radio link, I designed the frequency range according to this antenna, that is 3.3 gigahertz or 3300 megahertz, and the gain is 26 dBi, and the sensitivity is less 81 dBm. So these parameters are very important for the design. And we have the next slide where we have the radiation pattern of the antenna that is very important for the design of the radio. And this is the transmitter AF3X, that is the same vendor of the antenna. So we have a perfect choice here because there is no issue between the antenna and the transmitter. The transmitter works in a frequency of 3 gigahertz. We have here the technical specifications, where we can see all the parameters that the antenna have, the modulation that the system can use. And here we start with the calculations for the radio link. So the first calculation is the free space loss, that this shows the amount of energy that the signal loses in this path. So it is expressed in dBs. For this case is 133.57 dBs. The receiving antenna power indicates the amount of energy which with the wave arrive at receiving the antenna. It is determined by the following formula. We have the formula here, and the results is less than 60.86 dBm. The faded margin it describes the number of dB to consider the different geographical characteristics of the intermediate zone of the link. And this equation have some parameters that we have to take in account about the terrain. For example, this the roughness factor that is a have to say about the overwater or rough or highly terrain have different number for this parameter. Another is the factor to convert the probability of the worst month that has to be about the climate of the space where we are going to put the radial link. In that case, this parameter is 154.12 dBs. Later, we have the receiver threshold, that is the minimum energy that the system accepts. If any signal arrives with a lower energy level, the system omits this information. And this is the equation, and the result is less than 214.98 dBm. Next, we have the threshold margin. It indicates the quality of the link signal for the antenna threshold and receiving power. And this is the dBm level that the signal can be reduced without losing the link. Later, we have the signal to noise ratio, where we have 139.2 dBs in the calculations. For the Fresnel zone, in the link calculations, it was no necessary to identify the Fresnel zone because there is no issues with the line of sight. So we can see in the simulation that there is a perfect line of sight. For example, this is the simulation from the hill to the city, what we can see here, and this is the other side from the city to the hill. So we can see that there is no issue with that. Later we have the period that it's understood at the power that the antenna will emit, and is 52.86 dBm. Here we have the radial link simulation, where we have the parameters of the antenna with the results. As we can see, we have the parameters that we made the calculation. For example, the path loss. We have here the period. We have the receive power, and all that all that information about this simulation. Here we have the parameters from the other side. As we can see, we have the radio working perfectly without issues. And next we have a little brief about the radial link, where we have the different parameters. For example, the distance. We have the losses. We have the frequency that we have, the propagation loss, all that stuff we have here in this little brief about the simulation that we have. There is some calculation that we have to do for the data received in the simulation. For example, the fading margin, we have to calculate it, but with the data that we have in the simulation. So we have here all the calculations from the simulation that we have to do, and in the final part of this document, we have the comparison between the calculated that we made and the simulated that we have. So we have a percentage of error of 2.8 for pre-space loss, 6.4 for receiving antenna power, 11.4% for fade margin. So we can see some difference, but this is the one of the conclusions that we have here for this work, and is that the data obtained in the simulation are approximate to what was calculated, but not exact, as we can see in this comparison. And this is due to different aspects, such as the selection of the antenna, because the program does not have a satellite dish. It has only the Yagi antenna, so we have to use that antenna Yagi for the simulation. So that's one aspect that make a difference in the simulation parameters and the calculated parameters. So this is the presentation about the radio link, and hope that you take some knowledge about this and how we did it here in Universidad EXI. Thank you for watching this video.